And next up, so a very interesting, well, all of the projects are interesting, but this one goes into some specifics of Swarm. So Waggle project will present an alternative to current ways of communication, which aims to be much more secure and privacy preserving in many ways, as well as more spam resistant. So they are involved with Swarm for a while now and are really knowledgeable. So leveraging the cutting edge features the Swarm has to offer in this respect. So they will first have a presentation of their ideas and then a demo of the application they're working on. So please play the first video.
Thank you for the introduction, and good afternoon, everyone, and welcome to this exclusive preview of Waggle. The Waggle dance is the name of the communication protocol used between honeybees, and we have adopted this name and are currently developing Waggle as a spam-free, privacy-preserving, secure communication protocol on Swarm. So just like the honeybees, we envision that the bee nodes will dance when performing our protocol. Currently, we are only two working on Waggle, and that's me, Racin Nygaard, and Rodrigo Saramago, which will show you a demo afterwards. We are both students at the University of Stavanger. So before explaining Waggle, I will briefly talk about some of the problems that exist in existing email services. So the first issue is spam, and of course nobody likes spam, yet it's proven to be a difficult problem to solve over time. In traditional email services, when a sender transmits a message, it will eventually end up in the inbox of the recipient. The inbox is typically hosted by your email provider. Thus, a spammer consumes thousands of gigabytes of storage on the inboxes across the world. To combat this spam, the email providers run advanced spam filters, which require a lot of communication and needs to be constantly updated and fine-tuned, as spammers are constantly evolving and finding ways past this filter. Another issue with traditional email services are limitations on privacy. Many email providers openly admits that the emails are not encrypted and that they have the power to read it. Often they will disguise this by saying that they only scan for spam. Other services like ProtonMail encrypt the email, but they still access some of the metadata when using the spam filter. Even though SMTP is conceptually a decentralized protocol, this only accounts for the outbox. The inbox is centralized by protocols such as IMAP and POP3, which gives the email providers the power to deny any user access to their data. So now you might ask, what about Waggle? In Waggle, we have adopted an old idea called IM2000, where the main idea is shifting the responsibility of storing emails from the receiver to the sender. In Swarm, we implemented this by letting all messages remain in the sender's outbox feed until the recipient is ready to read the messages. This in itself would drastically limit spam, as now a spammer would essentially have to either pay someone to host his messages or he has to run a large server himself. In Waggle, we, however, take this one step further by requiring that the recipient pre-approves any communication. After accepting communication, the recipient establishes a secure end-to-end encrypted communication channel with the sender. We store all messages on the Swarm network. However, as they are encrypted, no unauthorized party can read them. So here's a big picture overview of the Waggle protocol. In the first contact, we send a notification from Alice to Bob, and if Bob accepts, both Alice and Bob will create an outbox, a secure outbox that only the other party can access. To transmit notifications, we use the PSS functionality of Swarm. These notifications contain the necessary information to start setting up secure communication. They are encrypted using the public key of the recipient and encapsulated in a Trojan chunk, which is delivered by the swarm network to the recipient's B node. By using Trojan chunks, we essentially force the sender to spend some communication in mining the chunk and thus prevent any spam of notification. Upon decrypting a notification, the recipient can choose to either agree or reject the communication entirely. If he accepts, we establish a secure channel between the parties using the swarm feeds functionality. The security of the messages will then rely on the double ratchet algorithm. So here's a more detailed communication flow or sequence flow of the notification protocol. After Alice retrieves Bob's contact information from a public source such as Keybase, or she can get it offline directly from Bob. She then notifies Bob using PSS, and Bob chooses what he wants to do with this notification. If Bob accepts, he adds Alice to his address book, and then he agrees with Alice to create an outbox feed. In this outbox feed, he acknowledges to Alice that everything is set up on his side, and when Alice receives this notification, she agrees with Bob to set up her outbox. After this, they have essentially established a secure communication channel between them. So when either of them now wants to send emails to each other, they can simply write the content and then they encrypt it using the keys that they agreed upon previously. And whenever Bob is connected to the swarm network and he is ready to read the messages from Alice, his Waggle client will pull the feed updates from Alice's outbox, and then he decrypts the content. And then as Alice will know that Bob have received the email, she will delete it, and Bob must then choose if he wants to make a backup. So he can either make a backup on Swarm or offline, or he can of course choose to discard it entirely. So I think that was enough talk, and now I will send you to Rodrigo, which will show you a demo of our prototype.
Right, so to start to use Waggle, the first thing is to log in, and we use MetaMask, so you need to log in your MetaMask account here. And here I will log in with 2 users, so I will log in here with Bob. And this one here, I will log in with the other user. That is Alice. Right, so Alice does not have Bob as a contact, so she needs to add his contact card. To do that, she goes to some social network, or she should receive this contact card from Bob or get it from any social network. So here, for example, Bob hosted his contact card on Keybase, and Alice can go there and download this information that will be necessary to establish the secure communication. So Alice download here the file. And after download, she goes to the contacts and click here to upload a contact based on the file. This is the Bob contact card information that is also here, right? So she can give a nickname for him, for example, like something like that, and add his contact. Yeah. So now Alice can send a notification to Bob to attempt to start the first contact with Bob. So, accept my contact, please, for example. And then she sends a notification. When she sends a notification, the notification is mine, and Bob received based on the overlay address of his node. So this will be, the chunk will be mine, and eventually arrive here a notification for Bob. Then Bob can accept or deny this contact, and if he accepted, this will automatically add Alice in his contacts, and will also send a notification back to Alice, telling that Bob accepted her. And this information here is also based on the contact card of Alice that they exchange using PXS. And now Bob and Alice can secure exchange emails using the feeds. To do that, for example, Alice can just go here and compose and send a message like, hello, Bob. See you here. And then she can send a message here. And this message will create a feed of which Bob is listening to. And then when the messages arrive to the node, Bob can retrieve and read the Alice's message. And Bob can do the same now because he will have the contact. And yeah. For example. And then eventually the message arrived for Alice. Sometimes took a bit until the yes, and so yeah, so this is basically the demo. If you want to know more about, we will publish a demo publicly, so you can interact with Waggle and use yourself and try yourself. If you are interested more in the project, you can reach us on GitHub or also by our current emails, or even using Waggle. This is our contact card, so you can send notifications and messages to us using this information. Yeah, so thank you very much for listening. Any questions?
Hi, hello. Yes, you challenged me, so hello. So I think this really shows great potential as a replacement for currently mainstream technologies, and we are really looking forward to seeing how this project evolves. But I guess the whole communication stack, so to say, could be replaced. But maybe, so could you share your future plans and what is yet to come?
Yes, of course. Well, actually, we would like to establish Waggle as a library for secure messaging communication in peer-to-peer networks. So this is our goal, to make it as an open source library, and we want to improve the app to represent the same user experience that you can get from the mainstream emails, and also allow people to install plugins and stuff to, start to use Waggle without too much dependence of the running a node, and eventually ease the migration to people from the mainstream emails to Waggle. So this is our goal.
Yeah, user experience is a big issue with current dApps, so to say. So looking forward to this. Thank you, Rodrigo and Racin.
Thank you.
And